Well, now let's look at one of my favorite areas. I am currently studying to be a CCIE in the area of Cisco security. I'm going to obtain my second CCIE certification in the area of security that I'm fascinated by. So let's talk about wireless local area network security. I'll have to know about some of this from a CCIE perspective, so let's have some fun with this. First of all, there are definitely threats here that are really a new category for us as security professionals to guard against. Wireless really opens yourself up to quite a bit of some new potential classes of attacks. I absolutely love this graphic. That guy right there is one of the geniuses at stormwindlive.tv. He does a lot of the cool technologies that you see that our classes offer, and it's a result of this gentleman here. And we cameoed him for this particular slide. That's him sitting outside the corporate office for that photograph. Funny stuff. Anyways, what he's demonstrating is he's war driving, a new concept where people are driving around with some Wi-Fi equipment and they're literally trying to intercept communications on poorly secured networks. Yikes. So this war driving concept is something that we are obviously concerned about. And as these exploits make big headlines, that really gives people huge concerns about their wireless infrastructure. And then the other thing we need to watch out for, and this is another photograph taken at our corporate headquarters, is rogue devices. It's easier than ever for people just to go home, go in the closet, grab their spare Cisco Linksys device and bring it into the office. And so we definitely want to build an infrastructure that protects against what we like to call these devices, these rogue devices. What a great term. So we want to make sure that our infrastructure, our wireless LAN infrastructure, is secure. We do this by attacking security from three main approaches. We want to make sure there's great integrity in the infrastructure. Integrity, when we talk data security, means ensuring that the data is not tampered with. My favorite story, and I hope I haven't already told you this story, that's embarrassing when I retell my stories, but my favorite story about this integrity dates back to like the Abraham Lincoln times. Abraham Lincoln would write a note to one of his generals, and then he would take that note and he would count all of the vowels, let's say, that are in that note. And then he would kind of discreetly write that number in the lower right corner on the outside envelope. When his general would get that note, the first thing he would do would take the note, count up the number of vowels and compare it to that number. If that number doesn't match, there's been an integrity breach in those communications. He knows that someone intercepted, put in a new letter, and tried to pretend they were Abraham Lincoln writing that. So this is a great example of controlling the integrity of the communications. And obviously, we're not going to use that counting of vowels approach today in networks, but we use a more sophisticated dynamic approach called hashing algorithms are often used to make sure that the information has not been tampered with in transit. Something else that we think of right away when we think about mitigating threats on wireless LANs is keeping the information encrypted. That's right, making sure we have a high level of confidentiality, making sure the information is encrypted to be kept from prying eyes. And then finally, great graphic, we take advantage of protecting the traffic. We mitigate against unauthorized individuals trying to come in and penetrate the wireless local area network and gain information, hack into our financial records, hack into our HR records. And one of the main lines of defense that we use at Cisco Systems is intrusion prevention systems. That's right, these really awesome network devices that analyze the traffic coming in, and it can tell attack traffic from benign non-attack traffic. Now, all of this just didn't get created overnight. There has been this real evolution in wireless LAN security. As a matter of fact, it started with the simple WEP, wireless or wired equivalency protection. I think that stands for WEP. It's them back in the late 90s trying to say, okay, this security will be just like you're on a wired infrastructure. Well, nice try. WEP is no longer considered adequate security for our wireless LAN infrastructures. The main reason that WEP, and I want you to memorize this, is no longer used today or recommended for use today is that there is this concept of a static key. You go up to your access point and you configure this static WEP key, and then you go out to your device and you configure this static WEP key, and that's it. The WEP key can indeed be hacked. And once the computer criminal gets that WEP key, they can hop on anytime they like. The key never changes, and that's one of the major issues with WEP. Also, if you're in a huge environment with WEP, you've got to run around and get that key distributed to everybody. It's really, really a problem. 802.1x was created in the early 2000s, and this allows for a much better way to authenticate someone on the network. They try and get on your wireless LAN, and 802.1x kicks in with its extensible authentication protocol, and it says, whoa, wait a minute here, who are you? Provide me some credentials. It uses dynamic keying information that can't be as easily hacked, and a very much improved encryption. But 802.1x is for really larger corporate environments. What went on for home environments? Well, two versions of WPA. Yeah, WPA has really taken over. WPA solves all the problems of WEP, and what's most exciting is that WPA can be done in two flavors, especially WPA2, the most modern standard. There's a kind of home personal use version of WPA that's very easy to implement. And then there's an enterprise level, a much more sophisticated level of WPA2 that we would use in a really big corporate infrastructure where we have more high-end equipment and we have more expertise to configure it. So very, very thoughtful of the security standards makers. They give us WPA and WPA2, which come in two different styles of implementation depending on the particular size of the organization that we are attempting to accommodate. Access points are very, very important in the wireless LAN infrastructure, obviously. And notice that how they typically work is they will go ahead and beacon out the ID for the network. The ID for the network is called the SSID, what we name our wireless LAN. So if you're at home and you have a dog named Spot, someone will often choose Spot's network as their SSID, and that gets beaconed out. When someone comes along with a laptop that wants to get on that network, they see, oh, look, the Spot network is accessible to me, and then they try and get on that network. There's a really kind of interesting approach you can take to security right off the bat with your wireless infrastructure, and that is you can go to the access point and you can configure the access point to stop broadcasting that SSID information. So now your wireless network infrastructure is kind of hidden. And this is one nice step towards some security. Now, certainly it's still there, and a computer criminal could find it, but it is an interesting little way to begin security by no longer having your access point beacon out its SSID information. If someone wants to get on that network now, of course, they need to be provided with the SSID that you are indeed using. 802.1x is so amazing. This is that technology that was invented for users to have to prove they are who they say they are by giving username and password information before they can access the wireless LAN infrastructure. Please notice it is 3 components, and I would memorize this because you'll need it in CCNA most likely, and you'll need it as you move beyond CCNA. 802.1x uses this concept of a supplicant. Now, I looked that up in Webster's dictionary, and a supplicant is someone that begs. And this is a perfect descriptor here. It's in our case, a Wi-Fi laptop that's begging to get on the network infrastructure of our wireless LAN. The supplicant begs to get on the network, and then our access point from Cisco acts as an authenticator. An authenticator that says, okay, I'm going to take your username and password information you just provided, and I'm going to check with an authentication server. Here we can see a AAA server that's authentication, authorization, and accounting services. And the AAA server will check that user's credentials. Maybe it'll even check what day it is, what time of day it is. And if all of that checks out by our security policy, it will go ahead and let that individual onto the network. Earlier on, I told you WPA and WPA2 operated in 2 different modes. The enterprise mode for the strongest of security mechanisms, and the personal mode for less strong, easier to set up mechanisms. You do need to memorize the technologies that are used for these different modes. So notice, if you look at this particular chart, you see, okay, well, the only thing that changes with WPA when we are doing the enterprise mode versus the personal mode is the big change is that in the personal mode, pre-shared keys are used. Okay, the encryption is TKIP in either case, but the big change is that for authentication, instead of using the complex 802.1x, you can just use pre-shared keys when you're in the home. Notice that's the same for WPA2. Pre-shared keys could be used in the home for authentication. The more powerful 802.1x is going to be used for authentication in the enterprise. For encryption, it's the Advanced Encryption System, AES, and notice that stays consistent. It's TKIP in WPA, and it's AES in WPA2. I know this can be cumbersome, and as a result, I tried to help you out over on our free blog site. If you go to our website and then you hit the blog, if you go down into the CCENT Wireless LAN category, so use the categories on the left-hand side, you'll see that I wrote an article here to help you out with this called WPA versus WPA2. And it's going to go through and help you out with the various technologies that are used for this wireless LAN security. Some of the buzz terms that we have in this particular area are, of course, WEP. We know that's that basic encryption with real serious issues, so it's not recommended anymore. TKIP, and TKIP stands for Temporal Key Integrity Protection, something along those lines. And this solves a lot of the problems with WEP. We see it used in WPA1. There's Advanced Encryption System, much better for encryption, used in WPA2. And the whole goal here is to create a VPN-like environment. VPN means virtual private network. It means that we're communicating using these radio waves, and even though we're communicating over the air, where someone could go in and listen to these radio waves, If they do that, they won't be able to make any sense out of the communications. They'll be kept private thanks to the wireless security mechanisms that we are employing.